So guys, today we will read about a refrigeration process, how it is start and how it becomes successful in our home refrigerator or any refrigerator which we are using in our companies, our business. Okay, so now firstly we will understand the flow diagram of this refrigerator. So this is the flow diagram. So basically the part of this refrigerator are shown here. And so the first part is evaporator, and this evaporator. Uh, Now the second part compressor, third part condenser, and fourth part is expansion valve. Okay, so expansion valve. Basically it comprises four part, which are shown here. So for understanding the overall process of this refrigerator, we have to understand the all the processes of the particular equipment, what equipment is doing here, and what working principle, in which working principle it is working. So firstly we will understand about evaporator, then compressor, then condenser, and then expansion valve. Okay, so firstly we will explain you evaporator. What is evaporator? Okay, so evaporator, the general work of evaporator is to evaporate any working substance. So guys, firstly we will understand what is working substance. For example, in petrol engine, working substance is petrol. Okay, and in diesel engine this is diesel. But in refrigerator it will a refrigerant. Okay, a refrigerant will flow. This is what we represent, that it is the flowing direction of the working substance. Okay, which we represent on this figure. Okay, so here a working substance is flowing continuously, and then cooling is occurring. Okay, so working substance, so when the main work of the evaporator is to convert the working substance into the vapor form. Okay, so here it is working substance. If you understand working substance. Okay, okay, so working substance basically it present in the form of liquid before. Okay, before it will in the form of liquid. Okay, but the evaporator convert this liquid form to vapor form. Okay, okay, and this is the main process of refrigerator. Okay, during this process cooling occurs. Okay, means heat of the things which we are placed inside the fridge, it extracted, uh, and this heat is catch by this working substance during its evaporation, or this evaporation process occurs in evaporator. Okay, okay guys, so evaporator basically what is doing, so I will give you some example. Let's consider here is sea or a river. Okay, a river is here, and here here is sun is located. We are observing in it at daytime. Okay, so when the radiation of the sun is flowing on this water, then the upper layer of this water will heat it up. Okay, and here some substance which is water substance, we will consider is like this. So this water substance or this molecule will heat it up. Okay, when these are heated up, then they will convert in the vapor form, and this vapor will go to the our atmosphere. Okay, okay, one example is this is also evaporation process or evaporation process. Okay, so this is occurring according to the nature. It is a nature process which is automatically occurring. Okay, but in refrigerator we have to make a equipment like that to doing this process. So the basic thing which we are why we are understanding you this process is that during evaporation of any liquid or any substance, it will consume some heat from atmosphere. Like here, the heat of the radiation of the sun, okay, is uh, sucked by this water, and now this water is converting in the form of vapor. Okay, so this is vapor. Okay, but remember one thing, guys. When the water will suck the heat, okay, then means the atmospheric heat is reducing this time. Okay, atmospheric heat is reducing this time, means heat is flowing from atmosphere to this water, and this water is now by consuming this heat converting into the vapor. Okay, so we can also say that the atmospheric heat is reducing here. Okay, I will give you another example of this evaporation. Okay, consider we have a jar. Okay, we have a jar here. Okay, and some water is in this jar, and a fish is also under this jar. Okay, my drawing is not too much good, so consider here it is a fish. Okay, so when this water is remaining filling for 2 to 3 days, you will observe that the quantity of this water will reducing. It is reducing time to time. Okay, consider in the first day you fill here 5 m cube of water in this beaker or in this pot. Okay, but after some time you will observe that it will 4.9 or 4.8 m cube. Okay, so here also the quantity of water reducing. Why? Because it is getting heat from the atmosphere, and this by getting this heat, the water molecule is converting into the vapor molecule. Okay, and now these are releasing in the atmosphere. Okay, so this is evaporation, or during this evaporation process, obviously the temperature of the water is decreasing, or the atmosphere temperature is decreasing that time. Okay, so this is the basic funda of evaporator. But in real practice in refrigerator, what type of evaporator we are using, I will show you here. So here the evaporator is mainly the tube type. Okay, a tube is formed inside a casing like this. In this tube refrigerant is filled. Okay, a refrigerant is filled in this tube. Okay, so here the refrigerant will present. Okay, so refrigerant basically if we consider water, okay, so its boiling point is 100 degrees centigrade. Means if we standardly talk about this, then we can say that in temperature of 100 degrees centigrade, the water molecules will convert into the vapor molecules. Okay, you can understand it. And if we talk about this refrigerator, so I will give you one example of this refrigerator, which is R134A. Okay, R134A. Let's consider we are filling here R134A, which is a refrigerant. Okay, its boiling temperature is about minus 15.34 degree Fahrenheit. Okay, and in degree centigrade it will be minus 26 degrees centigrade. Approx you will assume it. Okay, so you can understand when R134A refrigerant, which is our working substance, will consume heat uh, um, more than 0 degree centigrade, sorry, less than 0 degree centigrade, it will also evaporating that time. Okay, because its boiling point is minus 26 degree centigrade, so it will boil above the minus 26 degree degree temperature. Okay, consider we have minus 24 degree centigrade object. Okay, we are placed near it this R134 a refrigerant, then it will also sufficient to boil this refrigerant. Okay, means this refrigerant will get heat from this object, okay, which is in minus 24 degree centigrade, and now it will convert in the form of vapor. Okay, so we are giving you example of water, but refrigerant have its own efficiency, so that's why our refrigerator is working. Okay, so I have given you one example. Okay, so here refrigerant is filled. So during process, the evaporator is the main part, which is our let's consider this is our refrigerator. Okay, this is our refrigerator. Here racks are formed, and in this refrigerator, which is in more contact part, this is evaporator. Okay, this is evaporator like this. So during this process, working fluid comes from here and go out from here. Okay, and during this process, what happened? The heat of the things or fruits, vegetable, etc., will consume by R134 refrigerant. Okay, and it will convert in the form of vapor this time. Okay, so this is the main process. That's why the temperature under this refrigerator is reducing continuously. Okay, or it will reduce if we particularly talk about this refrigerant, and then it will reduce. It can reduce till the things temperature under the refrigerator is not getting this value, means minus 24 degrees centigrade. Okay, means this efficiency to reduce the temperature is minus 24 degree centigrade till minus 4 degree, minus 24 degree or minus 25 degree centigrade. We can reduce the temperature of the thing inside the refrigerator. But in actual practice, many assumptions are there. Okay guys, in actual practice, the efficiency reduces because of atmospheric reason, because of many more reason. Okay, so that's why the real efficiency is not gaining that time, but we can reduce the temperature inside the fridge, uh, um, less than 0 degree centigrade when we are using this refrigerant. Okay, so I think now you have understand this topic what I am saying. So now I will understand the other part. Okay, so the other part is compressor. Why compressor is important? This is most important. Okay, so now we will understand what is compressor. So guys, compressor basically work on this principle that it will gain the working substance which is in low pressure. Okay, and convert it into the high pressure substance. Okay, as I earlier represented here, it will gain the low pressure vapor which is coming from evaporator. Okay, evaporator, basically what is evaporator doing? Evaporator gaining the liquid refrigerant. Okay, and it is converting into the vapor. Okay, during this time the liquid refrigerator gaining its latent heat and converting in the form of vapor. Okay, vapor, and this vapor is now compressed in high pressure. The reason why we are using the compressor is the condenser. The if we not use the condenser, no, sorry, compressor, and then condenser efficiency will decreases. Okay, and we have to use very big condenser in our refrigerator. Okay guys, we will understand it step by step. So what is compressor doing? A low pressure fluid is coming, a low pressure vapor is coming on the compressor, and it is compressing it and converting into high pressure high pressure fluid, high pressure liquid, sorry, vapor. Okay, high pressure vapor. So what is the basic aim of this? We will understand by this graph. Okay, here a graph is represented. So guys, let's understand. We have water. Okay, in this point we have a water which is in 24 degrees centigrade. Let's consider. Okay, so we represented in y-axis is its temperature. Okay, temperature we are represented in y-axis, and in x-axis we represent the heat. Okay, so when we increase the temperature of this water, okay, water, then in 1 atm pressure, in 1 atm means 1 atmospheric pressure, which is 101,325 pascal. Okay, in 1 atm pressure and 100 degree temperature, when we give temperature of 100 degree centigrade to the water at 1 atm pressure, then it will convert it into the form of vapor, because the latent heat of the water is 100 degree centigrade. Sorry, the boiling point of water is 100 degree centigrade. Okay, so means now this phase will change. The liquid from, it will convert liquid into to a vapor form when we increase its temperature in 100 degree centigrade, but the condition is 1 atm pressure, at 1 atm pressure. Let's consider we have rises the pressure of this water. Okay, we have rises the pressure of this water at 2 atm, and now we will again rising the temperature of water to 100 degree centigrade. But now the water will not convert in the vapor form, because now its boiling point will rise. Its boiling point will go upside to the 100. Okay, in 100 degree centigrade we cannot convert into the water. Okay, so now in 110 degree centigrade, this is just an example, means these are not the exact values. At 2 atm pressure and 110 degree centigrade, it will convert into the water. You can basically understand about this, that when pressure is rising something, then we have to rise the temperature also to convert the form of any type of substance. Okay, so in 110 degree centigrade at 2 atm pressure, now water is converting into the vapor form. Okay, and now again we increase some pressure of this water to 3 bar. Okay, to 3 bar, and this 3 bar pressure, due to rising the pressure of the water to 3 bar, it is not, the water is not converting into the vapor phase in 100 degree centigrade. We have to rise the temperature also, so we are rising the temperature 120 degree centigrade. Okay, 120 centigrade, now this is converting into the vapor form, as we can show. Okay, this is basically showing the phase of this water. So this is liquid form, this is vapor form. Okay, and now this is showing that temperature is rising, because when we are converting the phase of this water into the vapor, then sometime it is taking to gain the heat. Okay, also it is taking to time to rise the temperature of vapor. Okay, rise the temperature of vapor. Now the overall substance temperature is rising here. Okay, you can understand by this. So consider that point in which we are rising the pressure of this substance to the critical pressure point. Okay, this critical pressure point is different for all type of substance. Okay, and this time we should heat the water to its critical temperature. Okay, then it will convert into the form of vapor. Okay, so now we can see that in critical pressure and critical temperature point, the water is directly convert, or the liquid form is directly convert into the vapor form. Okay, and we are not seeing here this phase in which in which this substance is remaining for some time. uh, just see, first time we are raising the pressure at 1 atm and temperature at 100 degrees centigrade. Then some time for this liquid is remaining in the vapor stage and then converting, then its temperature is rising after some time. Okay, but here it is a phase, then liquid is directly converting into the vapor form. Okay, now its temperature is also rising. So if we make here a graph which is represented by this red graph, okay, so it will come like this, it will come like this. Okay, so before, now this is as I wrote here, latent heat of evaporation. So latent heat of evaporation will rise, will be more if the pressure is less. Okay, latent heat of evaporation means heat required for converting the water or the liquid form into the vapor form. Okay, it will rise if the pressure of this substance will less. Okay, if the pressure of this substance is high, then we require less latent heat of vaporization. Okay, so basically you can understand from here that to rising the to converting the any substance in vapor form from liquid form, we should rise its pressure, and it is also reversible, means to convert a liquid from a vapor form to its liquid form. Okay, we should also raise its pressure. Okay, then it will get less heat. Okay, here we are rising the pressure, but it is gaining high temperature also. Okay, to convert into the vapor form. But if we rise the pressure, okay, of any vapor substance to convert into the liquid, then we will now we will want less less working substance of our condenser to convert it into liquid form. Okay, so basically I am going to understand you the main thing, because in compressor we have vapor. Okay, vapor, this vapor need more cooling agent or more water in condenser if its pressure will less. Okay, you can understand simply. Okay, if uh, if vapor pressure is high, then we require less safe condenser. Okay, and less working substance of it, like here water. Okay, here it is water. Okay, for this you can understand it simply. So now we will understand you the next component. Okay, so from compressor, low pressure vapor is converted into the high pressure vapor. Now we will go to the condenser. What is condenser doing? Condenser is basically converting the vapor form into the liquid form. Okay, vapor form to liquid form. Okay, how it is doing? Because if we have to convert any vapor into the liquid, what we will do, we will decrease its temperature. Okay, we will reduce its temperature. In summer season you can see that the bottle which we are taking from our refrigerator or any cool space, the outer surface of this bottle is filled with some water droplets. Okay, it is, that's why uh, because of the air which is touching the outer surface of this bottle, in its have also some water molecules are present in this. Okay, but when they came in the contact of this surface, and they will converting into the water droplets. Okay, they will convert into the water droplets because their condensation is occurring, okay. So this is condense. So now you can understand that the vapor form or the gaseous form is converted into liquid form when we reduce the temperature of this vapor. Okay, so this work is done by our condenser. Okay, so condenser is basically this. And why we need condenser? It is more important. We need condenser because in evaporator we need liquid substance, not vapor substance. If already vapor substance we will give into the evaporator, then it will not gain the sufficient heat from the things which we are placed inside the refrigerator. Okay, so when we will convert it into the liquid form, it will gain sufficient heat from the things and reduce the temperature of the things perfectly. Okay, so this condenser and this expansion valve. Why this expansion valve we are using here? The more its principle of its aim is to reduce the temperature. Means here from here the pressure is raised. Okay, but in this pressure, if we evaporate our if we operate our evaporator, then it will not work sufficiently. Maybe there some failure become in tubes, and some processes are not occurring in their real state. Okay, so we have to reduce the pressure of this high pressure liquid. Okay, this is high pressure liquid which we are gaining from the condenser. We should reduce its pressure, so that's why we are giving here a expansion valve. Okay, so the expansion valve reduce the pressure. We can adjust our pressure through this expansion valve in evaporator, which is required for the evaporator. Okay, now this liquid refrigerant also come into the evaporator. Okay, again it will gain heat from this things which we are placed inside the refrigerator, and now it will convert into the vapor pump. This vapor also now compressed with the compressor, and the high pressure vapor will go inside the condenser. It will condense. It will condense because here less temperature is generated by the water or any air. Okay, so it will again convert into the liquid form, and this liquid again goes the expansion valve. So this is now a reversible process. Okay, a cyclic process. Okay, now I think you all are understand this topic. So thank you for visiting my channel, and if you like this video, please like and subscribe my channel. Thank you guys.